All right, guys, let's get ready. You guys ready? All right, so let's start basically. Let's start with just reviewing how to simplify radicals really quick, because maybe we're a little rusty. So I know that the square root of 300 can be calculated really easy with a calculator if I wanted to have a decimal. If you have a CAS, it will tell you in radical form what the square root of 300 is. So here's my TI-84, which is the one that you guys have, and if I type square root of 300, it's going to give me a number, and I get 17.32. That's fine, but I don't want a decimal. 17.32. There's hundreds there. I don't want a decimal. I want it in radical form. So the way you do it is like this, guys. Square root of 300 is equivalent to, so two numbers that multiply to give you 300. So try to think of one that's a perfect square. So that's the same thing as saying square root of 100 times square root of 3, right? Because 100 times 3 is 300. And this is not the only way to do it, but this is one way. And the square root of 100 happens to be, do you guys know? So the answer is 10 square root of 3. This is probably the fastest way to go. Now, I'm going to change colors. If you have coloring pencils or if you have like a pen and a pencil, this would be a good place to change it up. 10 square root of 3 is the same thing as 17.32. Evidenced by just typing in this right here, 10 square root of 3. And you can see that's the same thing. See? Digit per digit. So let's say I don't go this route. Let's say I didn't remember that 10 times 3 is 300. You could say this, guys. You can break it down and you can go, well, I know that's 300, so I know that's 30 times 10, right? And then you can say, I'm going to keep making, this is what's called like a tree, like, keep like the branches. I'm going to keep going down until I have a pair of something. I know that 30 is 3 times 10. 3 times 10. Notice I have two 10s here. As soon as you have a pair, you can just take it out of the radical, and this becomes 10. And then what I have left under the root? Square root of 3. And there it is. 10 square root of 3, 10 square root of 3. Same thing. So it doesn't matter how you go. You'll always get the same answers no matter what. Does that kind of make sense, guys? Let's see. What else? Oh, yeah. In case you're wondering, like, why did you take this out? Why did you circle it? I don't understand any of this. Guys, the square root of x squared, the square and the square root cancel each other out. That's just x. I guess I can put like plus minus x or absolute value, but no, I'm just going to leave it like that. So all that means is square root of happy face. If I have that, that's just happy face, right? Now remember what the square means. So square root of happy face times square root of happy face. The square roots go away because it's the same argument inside the square root. So it's just happy face. I don't know if you guys like happy faces or not, but yeah. So anytime you have square root of 9 times square root of 9, that's just 9, right? Obviously, square root of 9 times square root of 9, that's also 81. So 9 times 9, see, they repeat, so 9. So make sure we understand the rules of what a square root is. It's the same thing with cube roots, right? If you had a cube root, something cubed, that's just x, because that repeats 3 times. X times x times x, that's a concept. So it's x. So that's why when they go cube root of 8, well, let's see. 2 times 2 times 2 is 8. 2 times 2 is 4. 4 times 2 is 8. So cube root of 8 is just 2. We're not doing anything with cube roots, but I just want you to know cube root, fourth root, fifth root, it does not matter. So if you were to type 8 to the 1/3 in a calculator, that will also give you 2. So there's so many different ways. You guys know about this. Is just laws of exponents. If you don't know it, or if you're freaking out, relax. We'll go slow. It's just that I like to throw all the different ways that you can see it because, I think it's good for you guys. I don't know, maybe you're like too much too soon, just give it to me slowly, then maybe, okay, I'll do that. Okay, are we okay, guys? All right, so look at this one. It says square root of 288. I'm going to go back to my shade of red. I know that square root of 288 is the same thing as saying square root of 144 times square root of 2. 144 times 2 is 288, right? And 144 is the perfect square root. Do you remember what the square root of 144 is? So 12 square root of 2 is my answer. And that's it. You're done. So whenever you get something like this, guys, see if you can figure out like what's the biggest square root that will fit into it. Let's say you don't know that. So, Chav, let me change the color here. I don't know that. How would I do it? Well, I guess I would start by using perfect squares. 2 squared is 4, 3 squared is 9, 4 squared is 16. So I guess what I would do is, does any of my perfect squares go into 288 evenly? So how do you do that? You just go 288 and divide it by any of your perfect squares and see if you don't get a decimal. So look, 288 divided by 16, I get 18. So that means, what does that mean? That 16 times 18 gives me 288. And I know that 16 is a perfect square. What's the square root of 16? 4, see? So as soon as you use that, that's it. That goes away. So this is 4 square root of 18. And Chavez, that's not the same thing as 12 square root of 2. Relax. The 18, I can break it down. What two numbers, when I multiply, give me 18? Try to get one that's a perfect square. 9 times 2, what's the square root of 9? So, look at this, guys. 4, that's that 4. The square root of 9 is 3, so that's that number. And the only thing I have left under the square root is 2. That's that one. It's under the square root because it's still under that tree there. So what's 4 times 3? OMG, look at that. We got the same answer. So it doesn't matter how you do it, guys. You'll get your same answer as long as you know what you're doing. So don't be a robot. Is this making sense, or am I going too fast? Or okay, if I'm going too fast, let me know. Or if you want me to explain something else again, let me know, because I can't read minds. Sometimes I can read faces. Sometimes when you look at me like this, when you look at me like that, I know that I lost you completely. But I don't see that right now. So some of you I can tell are kind of tired. So maybe you haven't been getting good sleep this week. Because I know when you're tired, because you're like. So I don't really know if anything's going through. But you're at least looking at me, and you're looking at this, and you're writing. But I don't know if anything is going through because you're just so tired that you're just trying to just float, right? All right. Anyways, properties of a right triangle. Let me know. Let me know if something doesn't make sense. Usually, in a right triangle, you have 3 sides. Actually, as a matter of fact, all triangles have 3 sides, but only the right triangle has a hypotenuse. The hypotenuse is the longest side. These are called vertices. Usually, you label a vertice with a capital letter. Sorry. And angle A creates little a, angle B creates little b, and angle C creates little c. And that's from geometry, right? And remember, what did we say? The longest side is your hypotenuse, so this side is always your hypotenuse. There is a famous theorem. Do you guys remember the name of that theorem? Starts with the letter P. Pythagorean theorem. Tell me what Pythagorean theorem is. This only works for right triangles. It does not work for obtuse, and it does not work for acute. You would have a greater than and less than symbol. But yeah, it is only for right triangles. The C is always the longest side. Always the hypotenuse. Always the hippo. Cool or not cool? Okay. So if I give you a triangle, let's just do one for fun, very basic. And I'm going to put a 3 here and a 5 there. And I know it's a 3, 4, 5 triangle. Not to scale. I know it's a 3, 4, 5 triangle, and you can figure it out really quick. I'm going to put X here. The hypotenuse is always the longest side. Always. So, how do I figure this triangle out? I would go 3 squared plus X squared equals 5 squared. And what you're trying to do, there's my expression right there. What you're trying to do is solve for X. 3 squared is 9. X squared stays as X squared. 5 squared is, not everyone at the same time, 25. And then to get the X squared by itself, you move the 9 to the other side. When I do that, it turns negative. So X squared equals 25 minus 9 is 16. And then to get rid of that square, I got to do an inverse operation, which means take a square root. Square root and square are inverses of each other. So the square root of X squared is X. And the square root of, whatever you do to one side, do to the other. The square root of 16 is 4. So there it is. X equals 4. Cool or not cool? All right, I'm going to do another triangle in sky blue. I'm actually going to do the same one, but this time I'm going to put 3, 4, and I'm going to put that as x. So you can see how to do this. It's the same triangle. Obviously, it's going to be 5. But if you have this situation, that's the hypotenuse, right? So on that one, you would have gone 3 squared plus 4 squared equals x squared. 3 squared is 9. 4 squared is 16. So 9 plus 16 equals x squared. 9 plus 16 is 25. So I'm going to write 25 equals x squared. And then to get the x by itself, I take a... So 5 equals x. So 2 different scenarios, guys. One, I'm looking for a leg. One, I'm looking for hypotenuse. The hypotenuse is always the longest side. Are we cool so far? So hopefully we've done stuff that you already know, so you're not freaking out. So here we go. I'm going to go to this next question. I'm also recording this. I'm making a video, so this will be the one I upload. Do you guys want to say hi to your classmates? Hello, guys. If you're watching this, hook it up with a thumbs up and consider subscribing. So give it a thumbs up so I know you're real. No, I'm kidding, guys. If you're not satisfied with this video, you don't have to. All right. So let's see what this says. Find the length of the missing side of a triangle with hypotenuse. Oh, what's up? Ask. Does someone have a question? I thought I heard someone with a question. Oh, I'm sorry, guys. Find the length of the missing side of a triangle with hypotenuse 2 squared to 29 and leg 4 units long. Simplest radical form. Okay, so radical form means the smallest, the smallest square root possible. So don't give me square root of 108. Reduce that square root of 108 into something. So not to scale. And it says the hypotenuse is 2 square root of 29. That's what it says. And a leg of 4 units. I'm going to put the leg right there. I'm going to call that x. So I just do Pythagorean theorem. X squared plus 4 squared equals 2 square root of 29, and put the whole shebang in squares. The 2 squared root of 29. I know you can put this in the calculator, 2 squared root of 29, and get me that answer. But for now, I want to show you how to do it. X squared plus 4 squared is 16. And here's how you do it. 2 squared is 4. And square root of 29 squared is 29, because the square root, when I square it, goes away. Is everyone okay with that? Okay. I'm going to rewrite it again. X squared plus 16 equals, and I'm going to multiply that 4 and that 29. Relax. You can do it with a calculator, I know. But you can also do it without a calculator like this. Here's how I would do it. 29 is really close to 30. I can do 4 times 30 pretty easily because I know what 4 times 3 is. 4 times 3 is 12. So 4 times 30 is 120. Does that make sense? Now that was not 30, that was 29. And you did that 4 times, 29 plus 29 plus 29 plus 29. So 30, 60, 90, 120, and then subtract 4 from 120. So that's 116. So that is 116. And that's how you think in your head. That's how you do mental math. That's how I do it. If you don't need gimmicks and tricks, then do it your way. Does that make sense, guys? Now, if you have a calculator, just type it into the calculator, no big deal. All right, next. You're trying to solve for x. So move the 16 to the other side. When you move it to the other side, I know that your previous teachers like to do minus 16, minus 16. That's fine. I just don't write that. I just write what it is. When I move it to the other side, it turns negative. So 116 minus 16 is 100. So there it is. And now the last step, x is not 100. X squared is 100. So how do I get x by itself? Take a square root. And it's a perfect square. So x equals 10. So there it is. How do you feel? You guys feel good? Okay. All right. Now I know it says enter Q from the DM handouts. Let's get decide. Yeah, scratch that out. I just didn't print it. I wanted to save some trees. Okay, give me your favorite numbers. Give me a number between 20 and 30. 25. Oh man, I don't know if I know that one square, but that's fine. Give me a number between 7 and 15. 8? I heard an 8. 8. Okay. Oh, did I already do a leg? Oh, I already did a leg. Okay, let's switch it up. Let's give the 25 here and the x here. So it's going to be big. All right. I don't know how it's going to come out. We'll find out right now. So let's try it out. I want to figure out what x is. That's the longest side. A squared plus b squared equals c squared. My c is that x there. So 8 squared plus 25 squared equals x squared. 8 squared is 64. 25 squared. Ooh, I know I should know that. 250, 215. 625. Yeah, that sounds about right. 625 equals x squared. And I'm going to add those two numbers together. 625 plus 64 plus 64. 689, right? Unless I did it wrong. 625, 35, 45, 56, 75, 85. What did I say it was? 689? 689 equals x squared. And I'm going to take a square root. And I don't know if that's a perfect square root or not. Let's find out. It's not a perfect square root. So leave it at square root of 689. Child, how did you know so fast? I didn't. I typed it in. What you can do, 689 divided by perfect squares. So let's see, if you don't get a decimal, that means that it could be broken down. So I'm going to divide by perfect squares. 4, 9, 16, 25, 4. Nope, decimal. So 689 divided by, what's the next one in line? 9. Nope, decimal. 689 divided by 16. Nope, decimal. 689 divided by, what's the next one after 25? Nope. 689 divided by, what's 36? Nope. 689 divided by 49. Yeah, you know what? That is a good question. How long should you go? I would maybe go like to 12, because 12, yeah, I would. 689 divided by, what, 64? I would think by the time you get to this one, you'd be like, you know what, we're safe. And leave it alone. Maybe that's not your best answer. But yeah, there it is. We're leaving it. Chav, when should you stop? You should probably stop by the time you get to like 15 squared is already 225. Let's see, what was it? 20 squared was 400. See, so just stop by the time you get to like half of 689. 689 divided by 400. Nothing's gonna go in. All right, leave it alone. Let's go to this one. So finally, we get into stuff that maybe we know, maybe we don't know. If you've been to a summer camp, maybe you're beast at this. Do you guys remember SOHCAHTOA? Okay. Are you guys beast at it?
Yes,
okay.
Absolutely.
So, it's an acronym, SOHCAHTOA. Yeah, sometimes there's some teachers that like give the acronym a little story. Some other hippie caught another hippie or something, Yeah, I'm not. Yeah. The S, all right guys, focus. The S stands for sign, so don't say sin, it stands for sign, S-I-N-E. The O stands for opposite, so I'm just going to put O-P-P. And the H stands for hypotenuse, I'm just going to put H-Y-P, so hippo. Cool or not cool? The C stands for cosine. The A stands for adjacent. And the H stands for hypotenuse. The T stands for tangent, the O stands for opposite, and the A stands for adjacent. Relax, adjacent just means next door. All right, it's a right triangle here, so this is always going to be called the hypotenuse. So angle A creates little a, angle B creates little b, whatever is opposite, that's what it creates. So angle A creates little a, angle B creates little b. And then angle C is little c, but I already wrote the name hypotenuse. Are we still okay? All right. So sine, and I'll write it here, these are for notes. So sine of some angle is always going to be the ratio of opposite over hypotenuse. Cosine of some angle, it always needs an argument. Don't just say cosine, it's cosine of something. Is always going to be adjacent over hypotenuse. Relax, adjacent just means next door. Tangent of some angle just means opposite over adjacent. Are we okay? Okay, we're going to go slow, guys, because I know, depending on where you're at, if you're in a summer camp or if your teacher talked about it, it just depends. Okay. Sine. So here's how you use this little acronym here, SOHCAHTOA. So sine, we already said that sine was opposite over hypotenuse, so that's what that O stands for and that H stands for. Sine is opposite over hypotenuse. So I look at angle A. I'm looking at angle A specifically. What is opposite angle A? Little a. See? Opposite angle A is little a. And then what is the hypotenuse is just the hypotenuse. I could say little c, but I'm just going to write hippo. I feel like it's more fun to write hippo. Are we okay right now? Okay. Cosine. I'm looking at angle A, and you're going to say adjacent. So what's adjacent? And you're right. So I'm going to slow down here because I want to talk about this. You guys are 100% right. The hypotenuse is adjacent to A, but that already has a name. That name is hypotenuse. Adjacent just means next door. So because the hypotenuse already has a name, what else is next door to angle A? B. So B is what we're going to consider adjacent, not the hypotenuse. Does that make sense? Okay. If you have a little brother or little sister, give them a cookie and tell them, take this to the adjacent room and see what they say. Like, oh, do you mean next door? See if he can use context clues. So B over hippo. Are we still okay, guys? All right, tangent. Opposite over adjacent. So we're going to say A over, what do you guys think? Yeah, A over B. Done, that's it. What do you guys think? All right, don't freak out. Do you guys know, have you guys seen CSC before? No? Okay. This stands for cosecant. C-O-S-E-C-A-N-T. So say that with me. Cosecant. Oh man, guys, come on, let's do better than that. Say cosecant again. Cosecant. Cosecant. One more time. Cosecant. Cosecant. All right, good. Good job. All right. Yeah, you guys did great. All cosecant means is the reciprocal of sine. Do you guys remember what the word reciprocal means? You're just going to, don't say opposite. Opposite means if it's positive, it's negative. If it's negative, it's positive. We're just going to flip. So if you have 1/3, the reciprocal will be 3. If you have 2/3, the reciprocal will be 3 over 2. So I have A over hippo. It's a reciprocal of sine. So if I have A over hippo, my reciprocal is going to be hippo over A. Now, if you see the words SEC, what do you think that one stands for? Secant. So that stands for secant. Say it with me, guys. Secant. 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 Don't you feel like you're in a concert, like when you're waving your hands and throw your hands up in the air and you're like, yeah. I always, okay, I know I'm going off on a tangent here. Off on a tangent. But every time I'm at a concert and I don't know why I have so much fun. You know, the DJ's always like, put your hands in the air. And I'm like, yeah. And everyone has their hands in the air. And I'm like, yeah, I'm having so much fun. And I always wonder, like, man, I can put my hands in the air whenever I want. I don't have to wait for this DJ to tell me. So I can have fun whenever. Like, yeah. But for whatever reason, on that concert, when the DJ's like, put your hands in the air, like, yeah. And then he's like, everybody jump. And I'm like, yeah, we're jumping. Like, you know, we can jump whenever we want, but why do we wait for that concert? Like yeah, everybody jump. And everyone's jumping. And like, you know what? Like, okay, anyway, sorry, guys. I like jumping. I like screaming. I like waving my hands. So all those things are fun for me. So when I go to the concert, when I go to a music show and they tell me to do all these things, I'm like, that's what I want to do. I want to move my hands. Yay. You know, like, okay. Sorry. Secant. It's a reciprocal of cosine. So the reciprocal is hypo over b. Hypotenuse over b. Cotangent, no one, oh man, I already said the answer. The COT, the cot, it stands for cotangent. And no one has issues with that. It sounds like tangent, but with a co on it. So everyone knows that that one's a reciprocal of tangent. That one's b over a. Cool or not cool? I'm going to give you an easy way to remember this forever. I guess it's a hack. So, okay, guys, focus. So I can give you this hack and you'll know forever. So how do you know the hack? So know these. Sine, cosine, tangent. Know them like the back of your hand. Sine, cosine, tangent. So know that. The reciprocal of sine is cosecant. Chop, how am I going to remember that? It's so simple. Look, sine starts with what letter? S. Look what cosecant starts with. It starts with a C. So if you see C as C, oh, that starts with a C. It's not an S. So that must be the reciprocal of sine. Look at cosine. Cosine starts with a C. And secant starts with a S. So the reciprocal, oh, secant. What is secant? Well, that's an S. So it must be the reciprocal of the cosine one. Do you guys see what I'm talking about? Now, don't get the sine and cosine confused. Like, wait, that starts with a C and that one's an S. That's a reciprocal of sine. No. Remember sine, cosine, and tangent. Those are the originals. Those are the goats. Those are the originals. Those are the OGs. The cosecants are reciprocal of sine. The secants are reciprocal of cosine. And then no one has issues with cotangent. Cotangent is reciprocal of tan. Those sound alike. Does that make sense? So there's your little hack. Secant. Oh, well, this is a reciprocal of which one? Is it sine or cosine? Well, secant starts with an S. So it must be the reciprocal of the cosine because it doesn't start with an S. Boom. So just remember, just toggle the letters. I know it's a weird hack, but it works. How do we feel? Okay. All right, let's go to the next one. I'm going to change colors. I'm going to go to sky blue because I think that's a pretty color. And I'm going to put angle, like there's my angle B in sky blue. So now I'm going to do sine of B. If you want, by the way, textbooks do a bad job. Well, this is not a textbook. I actually typed these out. Well, this part at least. I didn't type this in the bottom out. This was done by Gene Adams from your geometry curriculum, if you remember. So I took that out of that. But this in the top, I typed those out. And I just have the same bad habits that textbooks have. It should be sine of B, cosine of B in parentheses. Those should also be parentheses here. But the reason why they don't put them is because it's just understood. But it's just like f of x, guys. They don't say fx like that. They put parentheses on x. So it should have parentheses, but I just picked up bad habits from textbooks. Okay, are we okay right now? Yes. All right, sine of B. So remember, sine is what over what? Opposite over hypotenuse. So I go to angle B. What is opposite to angle B? Yeah, little b over C. I'm going to put hypo, but you can put over C if you want, if you call that C, because it is little c. Cosine B. Cosine is adjacent over hypotenuse. What's adjacent to angle B? A over hippo. By the way, don't call it hippo when you're talking to a professor. He's going to look at you and like, what are you talking about, hippo? I've just been calling it hippo since I was in high school myself, and I've always understood that. And when I talk to my teachers, I would call it hippo, and at first they'd be like, what are you talking about? I'm like, oh, hypotenuse. I just don't like calling it hypotenuse. I just call it hippo. So that's a bad habit of mine. Don't pick up my bad habits. I've had that bad habit since I've been a little kid. So sorry, I can't break it. I've tried to break it, but I can't break it. Tangent, opposite over adjacent. What's the opposite? What's adjacent? B over A. If you want to call it hippo, that's fine. To me, we speak the same language. Just don't call it hippo with a mathematician. It's hypotenuse. Okay, cosecant. What is my answer for cosecant of angle B? Yeah, hippo over B. I heard someone say it. What's secant of B? Hippo over A. And what is cotangent of B? A over B. You can also say adjacent over opposite. How do we feel, guys? All right, we're going to put this to practice. Here we go. I'm going to go to my shade of red. This says sine A, cosine A, tan A. This is from, I want to say her name is Gene Adams. Does that font look familiar to you? Or yeah, whatever. What was the geometry handout I just gave you earlier with the colorful SEL? Gina Wilson. So let's give her credit because we got to practice works cited. Do I what? Gina with a G. So Gina Wilson created this, and I just took that snippet. So thank you, Gina Wilson. It's because I just didn't want to draw these. Look, every time I draw these, look at how lame my. I don't know if you read this, but I made it in paint. So look how lame my triangle came, and it took me a while to do that, guys. I mean, 3-4 minutes. I know it just doesn't sound like a lot, but 3-4 minutes to do a dumb triangle. Not that it's. Okay, I'm sorry, guys. Look how much prettier that triangle is. You know, like, see, so I just like, man, Gina Wilson, I'm just going to take the snippet. So thank you, Gina Wilson. So yeah, so here we go. Because I could have made my own problems, but I just didn't want to take forever. All right, I'm going to put an angle A like so. Sine of A. Sine is what over what? Opposite over hypotenuse. What's opposite to angle A there? 5 over 13. Good job. Wherever this right corner aims at, that's your hypotenuse, or the largest side. Next one, cosine A. Cosine is adjacent over hypotenuse. What's adjacent? 12 over 13. Put that down. Tangent of A. What's opposite over adjacent? What is it? 5 over 12. Done. Let's go to angle C. I'm going to change my colors. I'm going to pick sky blue. So now I'm going to put it right here at angle C. Sine of C. Opposite over hypotenuse. What is it? 12 over 13. Cosine C, what is it? 5 over 13. Tan C, 12 over 5. Good job, guys. See? Basic. Let's go to number 2. I'm going to change my colors again. I'm going to go to W, sorry. All right, here we go. Sine of W is what? Oh, well, before we start, we got to find that hypotenuse, right? If you recognize it, that's a Pythagorean triplet, but if you don't know what I'm talking about, then just do Pythagorean theorem. I'm going to call that little y. So 9 squared plus 12 squared equals little y squared. 9 squared is 81. What's 12 squared? Is it 144? Equals y squared. And then 144 plus 81, is that 225? No? Yes? 81 plus 144? 225 equals y squared, and that looks like a perfect square because it is. Yeah, 15 equals y. If you recognize that this was one of those special triangles, it's not a special right triangle like 30, 60, 90, 45, 45, 90. We're going to talk about that right now. But it is something that's known as a triplet, Pythagorean triplet. All right, anyways, here we go. Now we got enough information. Let's see what we can do. Sine W, opposite over hypotenuse. So what do I write? 12 over 15, but before you finish, don't leave it like that. 12 over 15 can be reduced. 3 goes into 12 and 15. How many times does 3 go into 12? 4. 3 goes into 12 4 times. How many times does 3 go into 15? 5 times. All right, and it's no shame, guys. If we get it wrong, it's okay. Like, just, you know, there's a safe space. Cosine W. So I look at W, adjacent over hypotenuse. So I'm going to write what over what? Yeah, 9 over 15, which equals something 3 over 5. All right, and then tan W, opposite over adjacent, that's going to be 12 over 9, but that reduces to 4 over 3. Good job. I'm going to change my color to sky blue. It's going to say angle X, so I'm going to write my little angle there like that. And it says sine X. Sine is opposite over hypotenuse. So 9 over 15, which reduces to 3 over 5. Cosine X is adjacent over hypotenuse, which is 12 over 15, which is 4/5. And then tan X is finally going to be what over what? 9 over 12, which is 3 over 4. Pretty straightforward. I don't think we have any issues there. All right. Yay. Okay. Do you guys remember your special relationships between 30, 60, 90 and 45, 45, 90? Okay. If you don't remember, relax. It's okay. In a 30, 60, 90 triangle, the relationship is n squared of 3 and 2n. In a 45, 45, 90 triangle, the relationship is n square root of 2. Now, I don't want you guys to be a robot, so I'm going to talk about this right now. Chop, what are you talking about? This n square root of 2. That's a leg, and that's a leg, and this is also known as the isosceles right triangle. Isosceles right triangle. The leg is n, and the hypotenuse, according to this, is n square root of 2. Now, I don't want you guys to be a robot, so I'm going to tell you where this comes from. It comes from Pythagorean theorem. You guys already knew that though, right? So look, let's say I want to solve. So look, I'm just going to do my 45, 45, 90 triangle. So that's 45. All angles in a triangle sum up to how many degrees? 180. So if I put 45 there and I have a right angle, the other one must be 45. So you don't have to put it because it's known. And check it out. I'm going to write n. And I'm going to put x there because I'm trying to solve for it. Obviously, I'm going to get this answer, but let's see how. So I'm going to do Pythagorean theorem. You don't have to write this down, guys. You can just listen because I don't want you to be a robot, so I want you to really focus and pay attention here. N squared plus n squared equals x squared. Now remember, I'm trying to solve for x, right? So I have 2n squares there, so I'm going to add them up. 2n squared equals x squared, and I'm trying to solve for x. So I got to take a square root, right? Square root, square root. So from that, look at this. X equals, the square root of n squared is n, and then the square root of 2 stays inside the square root. OMG, n square root of 2, n square root of 2. Cool or not cool? Now, if you want, look at number 1. You could just do Pythagorean theorem all the time. That's 45 degrees. This is 45 degrees. So x must be 8. And then to find y, you could do Pythagorean theorem. So don't write this down, just listen. 8 squared plus 8 squared equals y squared. 8 squared is 64, so 64 plus 64 equals y squared. 64 plus 64 is 128. Don't write this down, guys, just listen. Equals y squared. 128, well, when I take a square root, this is the same thing as 64 times 2. 64 is a perfect square root. That is 8. So y equals 8, and look, you still have the 2 under the square root. So why would you want to do all this work over and over and over and over and over again when you can just memorize this property? This property up here, where are you, 45? N square root of 2. So if you just memorize that little thing, look how much simple this is. If this is 8, it's a 45, 45, 90 triangle, then x has to be 8, and then your y, you just put a square root of 2 next to that 8. Isn't that way better? Yeah, okay, now you can write, guys. Yes. Yeah, of course. All right. Here we go, guys. Look at number 2. You don't have to do anything. It's a 45, 45, 90 triangle. So one of the legs is 25, so that means y must equal 25. So if y is 25, x is the hypotenuse, x must be 25 square root 2. See? And that's it. Done. Uh-oh, look at number 3. Chop, I don't know if I'll be able to do number 3. Yes, you can, guys. I'm going to draw my 45, 45, 90 triangle right here, or my little relationship thing. And I'm going to put n square root of 2. And that 19 is the hypotenuse. I'm going to put a 19 right below it. So what that means is that n square root of 2 equals 19. I'm trying to get n by itself. This is n times square root of 2. So how do I get n by itself? I got to divide by square root of 2. I heard someone say it. So that means that n equals 19 over square root of 2. That's correct. That's a correct answer. But a lot of times, answer choices, if they're multiple choice, they're probably going to be in rational form. So what does it mean to rationalize the denominator? It means that they want the square root in the top. Why? Because a long time ago, they used something called log rules, and to figure out that was a calculator. To figure out what that value was in decimal, they had to have the square root in the top. At least that's what I was told. I don't know how much truth there is. I wasn't alive in the 40s and 50s, so I don't know. So I'm going to multiply this by 1, guys. So I'm going to multiply this by square root of 2 over square root of 2. Remember, don't be a robot. Anytime you multiply by 1, it's still the same thing, right? Anything times 1 is itself. Does that make sense to you guys? All right, so look. 19 times square root of 2, 19 square root of 2. Square root of 2 times square root of 2, 2. And there it is. That's my answer. 19 square root of 2 over 2. And I know what you're saying. Some of you maybe don't believe, like, Chav, I don't think that's the same thing. Yes, it is. Look, if I take my calculator, and don't worry, I'll go back, guys. 19 divided by square root of 2. And I push enter. I get that number. And then look, if I push alpha y equals enter, and I'm going to type this, 19 square root of 2 over 2. It's going to be the same number, guys. Same value. See? It's the same thing. It's just that they call this you rationalize the denominator. You took the square root from the bottom to the top. So that's what rationalizing the denominator means. So x is 19 square root of 2 over 2, and y is the same answer, 19 square root of 2 over 2, because it's a 45, 45, 90 triangle. Does that make sense, guys? Okay. Here's the relationship in a 30, 60, 90 triangle. I'm gonna change to a darker shade of red, just to differentiate. So a 30, 60, 90 triangle. The 30 does your small leg, so you always use the smallest as your reference. That's going to be n. The 60 degrees makes your longer leg, so that's going to be n square root of 3. And the hypotenuse is twice your short leg, so that's going to be 2n. Is it me or is it hot in here? It's hot in here? I'm sweating like crazy. Okay, short leg, n. Long leg, n square root of 3. Hypotenuse, 2n. Let's practice using it. You guys ready? So my short, this is 60 degrees. So if that's 60, this must be 30 degrees up there. 30 degrees creates your short leg. That's 5. So the x must be my long leg. So x has to be what? 5 square root of 3. And then y is double my short leg. So y has to be 10. Done. That's it. Cool or not cool, guys? All right, let's go to the next one. So this must be 60 degrees up here. That 14 must be my short leg. So to get my long leg, I just take the 14 and multiply it by what? So 14 square root of 3 is your y. And then to get x, which is the hypotenuse, you just double the 14, which is 28. Okay. I asked this to first period, so I'm going to ask you guys. Because, I like where the conversation is. Obviously, we know that the hypotenuse is the longest side, so everyone here knows that 28 is bigger than 14 square root of 3. But what if we didn't know that? What if someone just asked you, someone randomly in the streets, because you know how YouTube, there's always some random person like, what? Asking random questions. I don't know if you guys like that, but I do. I like to watch them. Sometimes it's too cringe and I can't watch because they'll ask questions. You know what I mean. All right, they'll ask questions like this. What's bigger? 28 or 14 square root of 3? We know it's 28, but what if we didn't, what if someone just asked you randomly without any reference, what's bigger, 28 or 14 square root of 3? Would you know? It's okay, you can answer. Okay, well look, here's how you can do it. Look, just focus it, just focus. How do you know which one's bigger? I know that square root of 3 is smaller than square root of 4, because 3 is smaller than 4, yes or no? Square root of 4 is a perfect square root. What's the square root of 4? 2. And I know that the square root of 1 is 1. Yes or no? Square root of 1 is 1. Square root of 4 is 2. So square root of 3 has to be a number between 1 and 2. 1 point something. I don't know what that something is. I really don't. Not off my head. 1.7, 1.73, I don't know. Something like that. Are we clear with that? Well, 14 times 2, remember, 2 is square root of 4. 14 times 2 is 28. So if 2 means the square root of 4, so the square root of 3 must be smaller than the square root of 4. So 14 times a number that's smaller than 2 must be smaller than 28. Because 14 times 2 is 28. Does that make sense? So there it is. So next time someone does a random poll on the street, who knows, maybe I'll get one of the seniors to have a camera and record, and we'll just poll one of you randomly. What is smaller, 28 or 14 square root of 3? 14 square root of 3. That's some first station with you. Okay. Hopefully you get it right. Okay. Sorry that we went off on a little tangent there. Tangent again. All right. Again, this one right here, 30, 60, 90. I would probably, maybe to help you guys out, I would go 30, 60, 90, and n square root of 3 to n. And then I would say that 32 is the hypotenuse, so I would put the 32 below the 2n. That's a 2 there. And then what does that mean? You can just write here on the side, 2n equals 32. So I want to figure out the short leg. So I'm going to divide both sides by, what am I doing? By 2, yeah. So n equals what? So the small leg is 16. Which one's the small leg, x or y? X, 16. And then the long leg, the y, must be, there you go. Good job. How do we feel, guys? All right, don't worry. We got a few questions, but they're pretty simple. So let's go to the next page. All of these little rectangles should have been triangles, but for whatever reason, it just didn't come out right. So put triangles on them. It says triangle ABC, the measure of angle C is 90. Okay, that's all you really need to know there. So ABC, not to scale. So that must be C, and then it doesn't matter where you put the A and the B. So angle of angle C is 90. CB is 3, so here's CB. BA is 5, and AC is 4. What is the value of cosine of B? So I emphasize angle B. I write my SOHCAHTOA. Once you're a pro, you don't have to write SOHCAHTOA. But for now, write SOHCAHTOA so you can know what is over what. I know that cosine, it says cosine of angle B. I know that cosine is adjacent over hypotenuse. So I go to angle B and I write cosine of angle B. You always need something inside the argument, inside the parentheses there. Don't ever leave cosine by itself. Cosine of angle B is what over what? 3 over 5. Done. Leave it alone. That's all they want. Cool or not cool? Yeah, that's it. That's it. We're done with that one. We'll go to the next one. Triangle ABC, the measure of angle C. So it's the same thing again. Here's my angle C. So A, B, C. CB is 36. BA is 85. And AC is 77. What is the value of tangent angle A to the nearest hundredth? Underline hundredth. So nearest hundredth. So I emphasize angle A, and it says tangent. So I write SOHCAHTOA again. SOHCAHTOA, or I guess you can reference it from up there. And I write tangent, and don't leave it alone. Make sure to put an argument there. Tangent of angle A is equal to, tangent is what over what? Opposite over adjacent. What's opposite? 36 over 77. It says nearest hundredth, so do I leave it like that? No, it wants nearest hundredth. That means I want a decimal. So notice the TH. I want a decimal, guys. So you take your calculator, and what was it again? 36 over 77? 36 divided by 77. Push enter, and there it is. Nearest hundreds. Where do I stop? 0.467, 0.46, 0.47. What is it? You round, and yeah, so to the second decimal place. So 0.47. So 0.47. Now, when you guys have physics and you have winners, and he doesn't ask you, he just writes, like, write the first 3 digits of the decimals or up to the third thousandths place or whatever. I want you guys to ask them. Someone raise their hand, and then ask them, do you want it rounded or do you want it truncated? Do you guys know what the word truncated means? Yeah, truncated means cut off, like the exact number. So if I told you round to the nearest hundredth, truncated, instead of 0.47, or did I say round and then say truncated? If I said truncate to the nearest hundredth, so we're not rounding, we're just truncating. That means you would have written 0.46, and you're not rounding, it's just 0.46. What word did I use? Truncated. So remember that. Truncated, 0.46. All right. How do we feel? Okay, here we go. We're about to raise your SAT and ACT scores. You guys ready for this? Look at this. Look at this question, guys. This is the question that I'm most excited about. In triangle QRS, the measure of angle S is 90 degrees. The measure of angle Q is 61 degrees. So let me draw that, not to scale. There's my angle S, and then that's Q and R. So Q is 61 degrees, and QR is 79 feet. Find the length of RS. Okay, I'm going to put an X there. To the nearest foot. Ooh, I love it. I love it. Okay. All right, so you're looking at this triangle, and you have this question on the SAT. So here's what you're going to say. Can you solve this question with Pythagorean theorem? No, because what? You only have one side out of the three. You only have the hypotenuse. To use Pythagorean theorem, you need 2 out of the 3 sides. So that's it. That one goes away. So then immediately you're like, okay, well then what do I do? And you remember, so yeah, trig identity, so katoa. Hey, that's a demerit, miss. You yawned. I'm gonna write you a demerit right now. I'm joking, miss. You know, I'm not. It's because you yawned. So I was gonna write a demerit, but you ruined the joke. So I'm not gonna joke around with you anymore. That was a joke, miss. You know I'm kidding, right? Okay. There's a safe space. You can yawn, I guess, if you're tired. Okay, here we go. Here's what you tell yourself, guys. You look at the 61 degrees, and you say this. With respect to the 61 degrees, is that x opposite, adjacent, or hypotenuse? Opposite. What about the 79? Hypotenuse. Which one of these three, sine, cosine, or tangent, uses opposite and hypotenuse? The S, the sine. So you're going to write sine, and you put the angle, 61 degrees is equal to opposite x over hypotenuse, 79. If you had winners with because you did a lot of this with forces and all that, this already looks familiar to you. I want to get x by itself, multiply by 79 to get rid of that denominator. So I'm going to say x equals 79 sine 61 degrees. And then you just take your calculator, and does it say to round to the nearest foot? Yeah, it does. And you just type that in. So take your calculator. Before you type it in, make sure that it says degree on that corner there. If it doesn't say degree, push mode and go down to the one that it says degree and then push enter on that. So here we go. I'm going to type that in. I'm going to push clear. Here we go. 79 sine 61, and I'm going to push enter. And there's my answer, 69 feet. How do we feel? Yeah. Yeah, let me know. Let me know. We feel okay, guys? Okay. All right. All right, here we go. Yay, we did it. We have 2 more questions. Don't worry, they're pretty basic. All right, here we go. Focus, 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 guys. We're almost done. We're almost done. Find the length of side x in simplest radical form with a rational denominator. So here we go. All that means is they want x. It's a 45, 45, 90 triangle, so I'm going to write that here. 45, 45, 90, n square root of 2. And I'm trying to figure out what x is. So I'm going to put a 1 right below the n square root of 2 because that's my hypotenuse. Whatever the hypotenuse, this is a hypotenuse, right? Hypo. So I'm going to write n square root of 2 equals 1. You're trying to figure out what n is, right? Because that's one of the legs. So divide by square root of 2. And yes, you could say 1 over square root of 2, but we want to rationalize it because it says in simplest radical form. Well, I guess it doesn't say. Oh, yeah, rational denominator. So I'm going to multiply this by square root of 2 over square root of 2. And I guess I should actually change the color for that. That's just a 1, so don't be a robot. That's just a 1. Anything times itself is just itself. 1 times square root of 2, square root of 2. And then square root of 2 times square root of 2 is just 2. So x equals square root of 2 over 2. How do we feel, guys? Okay, last question. And I'll go slow. Before I even get into this question, I want to talk about something really fast about inverses and reciprocals. So, side note, you don't. I guess you don't have to write this down. Just listen, guys. If I told you 5x equals 15, all of you would get it correct because you know all you got to do is just divide by 5, right? But what if I told you you can't divide? I want you to show me the steps, but you can't divide. So then you would say, well, if you're forcing me not to divide, then I'm just going to multiply both sides by the reciprocal. Or if they're integers, reciprocal and inverses are the same thing. So 5, negative 1, 5, negative 1, 5 to the power negative 1. These cancel out. X equals 5 to the negative 1 times 15. And if you take your calculator and you do that, put 5 to the power negative 1 times 15. And I wasn't looking, guys. So how come you guys didn't tell me? You guys didn't just saw me make a fool out of myself. Times 15. And there it is, 3. I could have also pushed this button. Did I push the power or did I push that button? I can't remember. 5 to this button. See that little button? Yeah. See? Does that make sense, guys? Okay. Now, you're probably wondering, Chav, I have no idea why you told us that. Because of this. So don't write this down. Just listen. If I have something like sine of theta equals, I'm just going to make it up. I'm going to put a half. And I told you I want to know what theta is. You can get theta by itself. This is just a side note, just like this. I can get theta by itself by doing the inverse of it. Don't call it reciprocal because remember, the reciprocal sign is cosecant. Don't call it reciprocal. Call it inverse. So how do I get rid of the sign to get theta by itself? By doing the inverse. So this is how it would look. Theta equals, and you were right, arc sine or inverse sine. That means inverse sine of a half. And then you would get your answer. So I would take my calculator and I would go, here's where sine of the negative 1 is at. Second arc sine, and I put the half in there, or 0.5, and I get my answer. Boom, 30 degrees. Does that make sense? So then I would say theta equals 30 degrees. Now, why do we need to know that? So we can tackle questions like this. This is a real life question, by the way. I wanted to put a real life question because I don't want you guys to leave without saying, when am I ever going to use this? I'm not going to be an engineer. I'm not like, when, well, look, you're an engineer. This is the question they gave you, your employer, your city. How do I pronounce this? San Joaquin? San Joaquin? Yeah. Anyone ever been to California? Okay, San Joaquin Valley. I don't know. In the grapevine. Yeah. Okay. Google it. Find out what's up. But it is a true question. Let's read it. Interstate 5 in California enters the San Joaquin Valley through a mountain pass called the Grapevine. This is all true. The road descends from an elevation of 3,500 feet above sea level to 700 feet above sea level in a slant distance of 5.5 miles. Approximately what angle does the roadway make with the horizontal? Okay, so here's what's going on. I'm going to draw a big triangle. Here's my angle. And this is a grid or a scale. And let me see if I can do this perfectly. At one point of the highway, you are how many feet above sea level? 3,500 feet. And then at the very other point on the highway, you are how many feet above sea level? 700 feet. And then this slant distance is 5.5 miles. Are we still okay? Okay. I want this angle, because that's what they asked. What is the angle the roadway makes with the horizontal? So here's how I'm going to get it. I need to figure out this displacement in my vertical direction, my vertical distance. Does that make sense? I was at 3,500 feet. Now I'm at 700 feet. What is the difference of that? 5, 6, 7. So 2,800. Let me know. I make mistakes all the time. 2,800 feet. Does that make sense? All right. Before I continue, I need that 5.5 miles in feet. How many miles in a foot? It's up there. 5,280 feet. I learned that from, there's a football movie. Can't remember the name of the movie. Oh, Remember the Titans. Have you guys ever seen that movie? And there's a scene where Petey drops the football and Coach Denzel Washington goes up to him and he's like, how many feet are in a mile? And he's like, I don't know. How many feet are in a mile? Yeah, like it's up there. Go to YouTube and watch that little skit. And he's like, 5,280 feet. You're killing me, Petey. Something like that. And that's how I learned how many feet are in a mile from that movie. I'm not even kidding. I'm being very serious. So 5,280 feet are in a mile. So dimensional analysis, I think in chemistry they called it stoichiometry. When you're a rookie, I would probably go like this. 5.5 miles in 1 mile, there is 5,280 feet. Miles cancels out and you just get feet. So take 5.5 and multiply by 5,280. So let's see. 5.5 times 5,280. Damn, that's a lot of feet. 29,040. 29,040 feet. Okay, here we go. Finally. With respect to that angle, is that 2,800 feet opposite, adjacent, or hypotenuse? What about the 29,040? Hypotenuse. Which one uses opposite over hypotenuse? Sine, cosine, or tangent, right? So could tell us somewhere. Sine. So here's what I'm going to write. Sorry, I was running out of room, but if you still have room, put it somewhere in the corner or whatever. I'm going to write sine of this angle equals opposite, 2,800 feet, divided by 29,040. You got to keep the units the same. I want to know the angle, so to get theta by itself, I take it starts with the letter I, inverse. Theta equals arc sine of this expression. It shouldn't be a big number, guys, because there's highway laws of like how steep roads can be. So it needs to be relatively small for the most part, but it's still actually like 3 degrees, 4 degrees is actually pretty steep already. All right, so I take my calculator, I push second arc sine, and I just type my numerator over my denominator. What was my numerator? Was it 2,800? 2,800 divided by, what was my denominator? 29040. Close it, push enter, and there it is. 5.5 degrees. 5.5, and put a little degree symbol. And we probably should have talked about degrees first and then go into this, but I was ambitious, so sorry if I got into this really quick. How do we feel, guys? Okay, here's my opinion. Here's just what I think. There is like a coloring activity. We put SEL. You don't have to color it if you don't want.